Greetings, my name is Stijn Calders, and I represent the Royal Belgium Institute for Space Astronomy, the lead organization behind the MOMSER initiative. MOMSER stands for Mobile Meteor Station for Education Outreach. Together with our partners, we have crafted a Meteor education kit tailored for secondary school STEAM teachers. But let me first explain you a bit about the research that we are doing. Every day, about 100 tons of meteoroids, from fragments of dust to sometimes big rocks, enter the Earth's atmosphere. Most of them are too small to be seen from the ground as meteors or shooting stars. Yet, they can be traced by use of radio techniques. As you probably know, meteors don't emit radio waves themselves, but they reflect them. So we have developed a radio network called BRAMS, consisting of one transmitter and 46 receiving stations spread across Belgium, with the aim to study these meteoroids. In the MOMSER educational project, we want to show this to secondary school children and to explain to them what we are researching and why it matters. The MOMSER kit has a mobile radio meteor station with a special antenna and radio receiver. Students can explore the exciting world of meteors, understanding their effects on the Earth's atmosphere and our planet overall. Simultaneously, the kit conveys a sense of fascination for the beauty and complexity of these natural light shows. By the way, the drawing on the box that you see on the left-hand picture is created by one of the students during an art contest. I will talk about it later. Through this project, we are using meteor science and observations to spark the curiosity of teachers and high school students in STEAM activities. This helps guide them towards potential careers in science or engineering. Radio meteor observations, especially during the day, are a great way to achieve this because they align with school STEAM curricula seamlessly. Our second goal is to encourage teachers and secondary school students to participate in the Radio Meteor Zoo, our citizen science project aiming at detecting radio meteor echoes on BRAMS spectrograms during meteor showers. BRAMS data is displayed as images known as spectrograms. Automatic detection algorithms attempt to identify specific patterns linked to meteor echoes. However, these algorithms cannot replicate the accuracy of the human eye, which remains the best detector. This becomes especially evident during meteor showers, which happen when the Earth passes through a cloud of dust particles left by a comet nearing the Sun. Spectrograms show many meteor echoes with intricate shapes during these events. The Radio Meteor Zoo project began with data from the 2016 Perseids meteor shower involving dust particles from comet Swift-Tuttle. We are asking people from around the world to help us with this project, including secondary school students. And finally, we want to reach the general public. During the school holidays, we will lend the mobile meteor stations to science camps organized by public observatories and science centers to demonstrate meteor science to the general public. In addition to making a direct impact, our goal is to indirectly engage a broader audience through online communication initiatives. We also encourage students to connect with their peers, incorporating into both the educational and artistic and design aspects of the project. We have education kits available for free download on our MOMSER website. These kits help teachers use meteors to explain geography, math, and physics concepts. On our website, you will discover materials available in Dutch and French. These resources explain the connection between comets and meteors, guide on calculating distances using Pythagoras theorem and demonstrate how to trace the path of a meteoroid. We also provide resources for creating infographics and science-based art. We're currently in the process of creating additional content about meteorites in Antarctica and variations in the meteor activity throughout the day. These resources are designed to demonstrate the application of abstract scientific concepts in actual research. Bringing the device to schools provides a unique chance to reach out to youngsters who might not have such opportunities otherwise. This includes children with disabilities or those from underprivileged families, both boys and girls. The artistic aspect may also draw in students with varied interests. Our concepts design increases the potential to connect with those who are often overlooked. During the project, we learned a few important lessons. Let's focus on two of them. Connecting educational material to learning goals is crucial for effective learning. It ensures that what is taught aligns with the intended outcomes, enabling a purposeful and structured learning experience. Also, communicating our research and its purpose in simple, accessible language poses a significant challenge. It necessitates breaking down complex scientific concepts into understandable terms without losing the essence and importance of our work. Finally, in 2020, we have received a grant from the European Public Engagement Funding Scheme. We deeply appreciate this. Thank you very much for listening.